Hello, my friends, and welcome back to another model of an atom. This is on page 31 of your student text, and I'm going to walk you through how to draw an atom of carbon by reading the periodic table. So let me first of all pull up the periodic table if I can find one. Remember to do this, I'm just typing in the term and the word image, and it should bring up what we're looking for. There are some beautiful periodic tables out there. When I taught all the time, I had a very nice one like this one, so they're really fun to look at. But the atom that we're going to be building today is carbon. So it's this one right here. If you see, there is carbon, which is number 6, and we're going to look at what these numbers mean and what that tells us. I also want to show you an atom of carbon image that is three-dimensional. We are going to look at a Bohr model, which is flat, but here is hopefully a little bit of a better image. I'm looking for a more here's a good one, I guess. This is more of a realistic image of what's happening as compared to the one that I'm going to draw, which is flat and not as easily. Here it shows you both. The flat one is the Bohr model, or a form of it, and the other one is 2. It's just a three-dimensional version. So I want you to know that these in real life are not flat. They're going to be three-dimensional. There's a good one too. Okay, so let's go back to our diagram, and I want to start with this because I got this from the periodic table. I just clipped out that little box for carbon, and I want to tell you what this says, how to read this. So the first thing that is probably the easiest thing to know is the element name. So this element is called carbon. Remember that elements are pure. It's not mixed with anything. It is pure carbon. And then we have this thing, which is called the atomic number. And not all periodic tables are the same. Some of them will put the atomic number up here. It just depends on your particular table. But the atomic number tells me the number. It says how many protons. And remember, every time I write proton, I write plus to remind me of what that means. This is called the chemical symbol. So when you write chemical formulas, and we're going to do some of that, you don't want to have to spell out carbon every time. That would get very complicated. So this is a chemical symbol. It is a capital letter. If it had a small letter beside it, that would be a lowercase, but the first letter is capitalized. And then this last number is called the atomic mass. And I'm not going to explain that just yet. We will come back to this, but I want to do something first. So let's go ahead and name that the atomic mass. Okay, so let me highlight. I'm going to highlight atomic number with yellow. That's this. I'm going to highlight atomic mass with blue. That's this one. The element name, let's go ahead and highlight that. That's something that if you need to know how to spell your element, you've got that right there. And then the chemical symbol. So these 4 pieces of information are given to you on a periodic table. So what does this mean? How does this help me understand an atom? Well, and one thing I need to show you is that the number of electrons, nowhere does this mention electron. So let's come up here to our model, and I'm going to go ahead and draw myself a circle so that I don't have to keep doing this. And I'm going to copy that. Okay. So the first thing it tells me, let's start with the atomic number, is that there are 6 protons in the nucleus. Now it doesn't say they're in the nucleus. We have to know that. So let me copy this one. Let's put 1. I'm trying to do this the short way and it's turning into the long way. Okay, let's try this again. Bear with me, I'm so sorry. This is just slow going here. I want to copy. Okay, I'm going to draw it. We've got 6 protons. So let me go ahead and pick up another one here. There's 2, 3, 4. This is much easier, isn't it? 5, 6. And protons are what kind of particle? They're pluses. So that 6 down there in my little box says to put 6 protons in the nucleus. And I colored those yellow, so let's go ahead and do that here too. 1, 2, 3, 4, 5, 6. That is what makes carbon. Oxygen is going to have 8 protons in its nucleus. Nitrogen has 7. Hydrogen just has 1. So that number of protons is what determines the element that you're looking at. Now, what do you know about positives and negatives? Opposites attract. So we want to balance this atom. We want to stabilize this atom. Remember, you never put electrons in the nucleus. They're not allowed in there. So let's go ahead and draw one. Here's one, and it has a negative charge. I need another one. There's another one. How many electrons am I going to need for this to balance? Well, remember what I showed you. Opposites attract. So we're matching them up 1 to 1. That means there are 4 of these guys that still need an electron. But Mother Nature has a very picky rule. She says that you can only put 2 electrons in your first shell. So we're going to have to move out to the second shell. And it doesn't matter where you place them, as long as they're in the right shell. And we need a total of 6 of them. 1, 2, 3, 4, 5, 6. We've got it. These are the negative charges. So let me color these in so you can see them clearly. 3, 4, 5, 6. So this is a stable, balanced atom of carbon. It's got 6 pluses and 6 minuses. But we don't have any neutrons. And we don't have to. It's okay if we don't. But in a perfect carbon atom, you will have some. And here's how I know. Do you see this atomic mass? This fella is supposed to weigh 12.011. That's the perfect weight of a carbon atom. So let's come back up here. We need the weight to be in the nucleus, not in the cloud. The weight has to be in the center part. So I've already got 6 in the nucleus. We've already got 6 of them right there. So let's add the weight. 7, 8, 9, 10, 11, and then this 12th one, I'm going to make him just a little bit bigger to cover that 0.11, okay? Now, so I've got 12 in there. That's the weight of the atom. I can't make them positive though, because that's going to mess up my balance with my negatives. This is where those neutrons come in that are not charged. They're just neutral particles. They're giving you weight here, but it does not change the balance of your pluses and minuses. You still have a balanced atom, because these don't have a plus or a minus. They're no charge. They're just the extra weight. So this is a beautiful model of a carbon atom, one atom of carbon. This is pretty complicated, guys, to understand. This stuff in the periodic table takes a lot of practice. You are not going to have to draw one of these on your high set exam. You might in other exams, but I don't want you to lie awake tonight worrying about this. I just wanted you to understand how the periodic table and the model go together. And please, if you have questions, contact me and we can look at some more examples, or we'll get this figured out. But I hope that this has been a fun exercise, at least more fun than writing definitions. In the next video, we're going to look at molecules, and that is what we get when we put two or more atoms together. So we're going to look at that in the next video, and I will see you soon.